All right. Oh, that's too much going on up there. So a couple big ideas coming out of today. We're going to talk about the normal curves in just a minute, but I asked you guys to look at this here. Density curves. My uniform distribution is going to kind of look like a rectangle. Down here, it's going to go out to whatever our value for k is. Up the y-axis, it's going to go up to whatever 1 over k is. How do you find the area for a rectangle? Yeah, length times width. So if I do my length of k times my width of 1 over k, gives me an area of what? 1. That's why we have an area of 1 underneath this uniform distribution. We'll talk about why these others have an area of 1 underneath their curves. But uniform distribution happens whenever I have an equal chance of any one of the available options there. Like rolling a die, it's always a 1 out of 6 chance. If I handed you a die with 10 sides, it would be a 1 out of 10 chance. Just kind of our luck of the draw there. We have our 3 distributions that are not uniform distributions. We have approximately symmetric, where the mean and the median are about equal. Skewed right, the mean is going to be pulled into those higher numbers. The mean is going to be larger than the median. Skewed left, the mean is going to be smaller than the median. These approximately normal curves right here, these symmetric curves, there are some special rules that apply to those. So we're looking at 1 standard deviation away, 2 standard deviations away, and 3 standard deviations away. That's what those little lines are there for. And I know some of them didn't copy super well, but can you kind of see where those little gray lines are in the back? All right. So for our, hopefully this actually works for me. Get smaller, don't go away. Yay! For our stopwatch trials, let's look at what the standard deviation is here. What was our standard deviation? 0.211. What was our mean? 4.966. That's really close to 5, right? As a group, we almost nailed it with that mean. So 4.966 and 0.211. So 4.966. I want you guys to label this on your paper. And our standard deviation was 0.211. As we move this direction, we're going to add the standard deviation each time. If somebody could grab a calculator for me so we can get these numbers on here. What is 4.966 plus 0.211? 5.177. Can you add 0.211 again? 5.388. And then let's add 0.211 again. 5.599. When we go this direction, instead of adding my standard deviation, what do you think we're going to do? We're going to subtract it, so minus the standard deviation. 4.966 minus 0.211 would be 4.755. If I subtract 0.211 again, I would have 0.544. And if I subtract 0.211 again, I get 4.333. Within 2 standard deviations of the mean. So I'm looking at this space right here. That captures 95% of all of our data. So what percentage would be beyond 2 standard deviations away from the mean? 5%. So these little tails over here together represent 5%. What percentage of the data is greater than 1 standard deviation above the mean? Well, now we need to talk about how much is contained in 1 standard deviation above the mean. So this space right here, that is 68% of all of that collected data. What percentage of the data is greater than, so I'm only looking over here, what percent would fit in this tail over here? I'm going to outline that in green. What percent do you think would fit over here? What'd you say? 16%. Let's talk about how we got that. How much of the data falls from the middle and then over that way? Half of it, right? Well, if this middle section is 68, how much is just this part of it right here? 34. So I take half of it plus another 34, that'd be 84%. Do 100% minus 84%. That's how we get this little green section as 16%. What percentage of the data is between z-1, that's 1 standard deviation below the mean, and z equals 2, 2 standard deviations above the mean? What do we think? So I want down to here, and I want to go up to here. Let's see, I'm going to draw a picture here. Here's my mean. We know that this is how much? That's 68%. If I take it out to 2 standard deviations on both sides, I said that's how much? That's 95%. So I know I need that 68%. What's the difference between 68 and 95? Is it 17? 17, or 95 minus 68, 27. What's 27 cut in half? 13.5%. So over here would be another 13.5%. So what would it be if I look at 1 standard deviation below up to 2 standard deviations above? 81.5%. When we're looking at stuff that is approximately normal, we have a rule called the empirical rule. That's what we've been applying right here, is the empirical rule. Sometimes the empirical rule also gets called the 68, 95, 99.7 rule. And if you flip your paper over on the back, that's what I have drawn right here. 68, 95, 99.7. 99.7% is 3 standard deviations away on either side from the mean. It captures almost 100%, just a little bit shy. We got 0.3% spread between these two tails. So 0.15% and 0.15% over here. By the way, that symbol right there, it kind of looks like an O with a tail off the top. This is the symbol that we use for standard deviation. This symbol right here, it's a mu. This is the symbol that we use for the mean. We are only 2 minutes away from the bell. I want to finish up the bottom part of this page tomorrow, and I want to grade the homework tomorrow, and then we'll roll into the next exercise. I'm not going to collect the homework from you today. I will pick it up tomorrow, and I will answer any questions you guys have about it then.